What's the record? Okay, there we go. And let me share my screen with you and share C++ so you get to see what I'm writing. Let's start new one today. File new and source file. Let me just show you one of the things I can see out is using manipulation, IO manipulation. So let me just quickly explain this program. I don't know. Displays 3 rows of numbers. Nothing really fancy. Every program that we write should have this in it, pound include. IO stream, input output streaming. Using, if you did the homework assignment, the first 2 questions was put these in using namespace std. There's this table too.
I need plug.
Oh, this one here, actually, there's a plug too for reaches. If anyone needs a plug there. INT main.
You have one near you, plug?
There's this one here.
I'll take this.
Yep. Curly bracket to open it, curly bracket to close it, return 0. Anytime I start a new program, you're going to see me type these in every single time. Sometimes I'll add to them. But this is the basic. This is actually the minimum that you need to put there. Let's say I have some numbers here.
Will the program fail if you don't have the include ISO stream?
If you're going to use CN and C out, yes. It won't work. Just like if you want to do some math, let's say sine, cosine, or square root or power.
It won't compile.
Yeah, yep, unless you say include CMath, you know. So I'll try to bring all these in today. So let me actually take some numbers. Double. I'll make them double decimal values, the numbers. And 259.7 up, num1. Num1 equals, I'm assigning a value, just want to show you something here. Then comma, up, comma, num2 equals 125. It's a decimal value, but this doesn't have a decimal value in it. Comma, num3 equals 4.875. I don't know. Comma, num4 equals, I don't know, 21 or 22, whatever numbers you want to put there. It's not a big deal. Comma, num5 equals 7.365. Comma, I'll do like 9 numbers. Num7. Oh. Num8 or num7, num6, I guess. Num6 . 1623, a comma, num7, 12.76, 9, num8, equals 0.5. And the last one, num9, equals 2. And that's it. Now, let me just go here and just spit these numbers out. So I want to see these numbers. I can say C out. And let me put num1, print num1, print num2, print num3. And when you finish with that, go to the next line, end L, new line. And let's repeat that, copy and paste it, and do 4, 5, and 6, the rest of the numbers. 3 lines, I'm going to do this. I should have brought a mouse with me. Copy. And let me paste it here. Control V. And Control V. So for this, I'm going to do 4, 5, and 6. Seven, 8, and 9 here. And if I save this one, file save as, and let me call, today is what, February 8th, is it? 10th? Or 9, wow. February, up. Yeah. February 9th. And let me compile and run. Come on. And here are the numbers. The problem with the numbers, they don't look nice. Like you don't even know where the first number starts, where the second one ends. Look at this, 259.71254.876.
Yeah.
I don't even know if the first number was 259 or 259.7. So it's hard to tell. You say, well, what about if I put space here? Well, just do this, put a space after each number. Oops, I didn't mean to do that here. So write the first number, put a couple of spaces. I don't know how many spaces, I'll make them consistent. Put 2 spaces, write the second number, put 2 spaces, go to the next one, write the fourth number, put 2 spaces. I just realized the software does actually, when I do a double quotation to open it, it does automatically puts a closing one. I wish they don't do that because just a habit of me. And we'll do the same thing here. I didn't put one after the 9th number because I'm going to the next line, so it doesn't really matter. So if I save this, let's see if that looks better. It's going to look a little bit better, but still I'm not happy with it. Give it a few minutes. They don't line up nicely. See how the first number, there's the second number, the third number, but they don't line up. Will be nice if they all line up the same column. You know, number one right here, number two right here, number three right here. It'll be nice if they line up nicely. We can actually make them line up nicely by using something called set width. Set the width of each number. So you want to look at the biggest number that we have there, and the biggest number looks like has how many numbers in it? 4, 5 maybe? 5. So if you want to put spaces there, you can set the width to 7th. 7. So instead of the space here, I can go before each number and say set width. So before number 1, I can go set W. That means set width to 7. And do that first number. And never mind that extra space here. We'll do set width here. You want to put them before the number to 7. You want to do set width here. You don't really need it for that one, but since I have the space, set W to 7. Set the width of each number to 7 digits. Even if it's not 7 digit, we're going to put extra spaces, leading spaces. Set width 7. Set width to 7. Set width to 7. So make each number 7-digit long. We'll do the same thing here. Set width to 7. Set width to 7. And the last one, set width to 7. And if I save this and run it, it's not going to work. It doesn't know what set width is. That's something we added after people created actually C++. So if you want to do that, you need to go here and tell the machine, pound include, go get. IO manip, input output manipulation. Get the program, the piece of the program that will do input output manipulation, which means now we'll know what set width is. So if I save this and run it now,
Switch that 70 to a 7 first. That
which one?
Third row.
Oh yeah, 70.
That's gonna be
Yep.
big.
7. Let me save, thank you. And compile and run. Now we should know what set width is. And look at the numbers, all aligned on the left side. I mean, on the right side. Some numbers have decimal places. Some numbers don't have decimal places. Some numbers have 3, 4 decimal places, you know. And sometimes if you have a big number or a small number, that number is written actually in scientific notation. What about if you want to have like 3 decimal places? Every number 3 decimal places. I'll leave that one there so you get to see it for, if you see it on the homework assignment, what set width does. It makes each number 7 digits. For example, the 2 is not 7 digits. Notice you have 7 digits here, 6 empty spaces before that number to make it 7 digits. let me do something else. So I'm going to leave this one here. I'm going to show you another piece here. What about if I put here after that, C out? Let the number show up as number, non-scientific notation. We write fixed. Fixed, that means I want the number to have a decimal value, not a scientific notation. I want you to show precision, or show point, show the decimal point. So if the number does not have a decimal point, put it in. And also, I want each number to have maybe 1 or 2 decimal places. That's set precision. How many decimal places you want? 2? Set precision to 2.
Does fixed have to have parentheses
Nope.
if it's a function?
Nope. Just write fixed, show point, and set precision, just the way you see them. If you write fixed in double quotation, then it's going to write the word fixed, you know. And let me actually see out, just to show you. Let's put the 3 numbers here, num7, num8, and num9. Show me the last 3 numbers using this format, end L. Let's see what these numbers, you get to see them above and below that comparison.
Might help if we put a new line after this.
You can do a new line, but notice 12.77, because it rounded that number to 2 decimal places, 12.77 for the first number, then 0.0504, 50, 2 decimal places, 0.50, then the next number is 4.4. Did I say num9, the last one? Because that's supposed to be a 2 here. The first number would be 12.77, but then this number 0.50, and this number should be, let's see if I
It took num3. It looks
did. I
like.
said, oh, I did say num3. That's why. Num9, you know. And here is a 2.00. Now, again, if you want to put spaces between them, because each number is what, 4 digits, the biggest number is 4, you can make them 5 or 6, set width to 5, you know. I can go here, set width, maybe 6, I'll make them. Then set width to 6, and set width to 6. Save it, and compile and run. Oh, missing parentheses.
Yeah, that ought.
It's good if, but I tend to type everything over it. Go away. The other one's good. And look at the numbers. Every number has 2 decimal places. So if I put that statement really on the top of the program, all 3 numbers here, all 9 numbers will be nice and neat. I'll show you. If I took that statement out If I took that one out, copy, and I put it before the first C out, put it there. All the 9 numbers under it, gonna have that format. Fixed, show decimal point, 2 decimal places. So my numbers now will be like nice and organized. I gotta put it before, I only put it in front of the first line, but I gotta put it in front of the other 2 lines. Let's go right here.
Can you put your set W's in with the fixed show point and precision?
Oh, you want to put it here?
Does that work?
Well, let's try. Set width. The question, can you put the set width here to 5? Or 7? What was it? 6, 7 we're using here?
Well, can you take can you put your set widths up there in that first sentence and just get rid of them in all the other?
Well, let me show you.
Because that cleans up code. Just
Yep, let me just show you. Let me just not put it. I'll leave the other ones. Well, I'll take 2 of them out because then I gotta type them in. You get my answer, I think. The question, can I just put the set width up there and see if the machine knows I want them all to be 7 digits long? Num1, num2. Oh, I have an extra set because I delete stuff. It didn't recognize that. So the set width, if you put it up there, is not going to work.
Okay.
So let me copy this. Cut, I guess. And paste it here. And paste it here. And paste it here. And let me take this one here. Copy. And save changes, yes. Oh no, did I close it? File open. Today is what, the 9th? Set width, okay. Oh. I copied this, but I guess I didn't copy it. I definitely need the mouse here. Copy. Control V. And Control V. Oh, you know what? Because I said they set the width to 7 and some of them are 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Fix, show decimal point, set precision to 2. Set with 7, set with 7, set with 7. I have 1 down. Oh, I have 6 here. 7. Might want to make it like 10, 20. Sometimes if you make it really big, it puts a lot of spaces between them. And I might want to make it bigger to separate some of the numbers because it looks like this second number is much bigger. But notice they line up here. But this number here 1, 2, 3, 4, 5, 6. That's why. So let's make it like 8. Then all the numbers will line up nicely. Instead of 7, instead of 7, 7 wasn't big enough. That's why the second number doesn't have a space between them. So if you make it 8 or 9 for all of them, 8, 8, 8, 8, and 8 here.
Now, could you make that like that number of variables? So
Sure, you can read
just,
that
like,
number.
Here to, if you
Well,
want.
You can read the number. Yep. You can call it size, and just define it on the top to be. That's actually a good idea. Like W, for example. Set the width to W and define W on the top as 8. And if it's too small, make it 9. If it's too small, make it 10. That's a very good idea. Instead of saying always going to be 8. So you can just run it and see if you like it or not. And here's the numbers all line up nicely, Did I really have to write this statement 3 times? So let me take it out and see if it changes anything. And look, once you write them once, it's going to remember that till you change it again. So if you want to stick with that look there, write it once before you print, and the machine remembers that and applies that to all the numbers. So you don't have to write that 4 times, 5 times, 6 times. Yeah, there's a mystery how to enter this. So notice I only wrote that once now. I took the other ones out. My output's still nice and neat. I do like the idea of making, somebody suggested, make int w equals any number you wanted, for example, 10, and set the width to w now. So you never have to worry about it. Just if you decide that's too low, just change w from 8 to 9 to 6. Okay, so now I can run it, and I have w as 10, and if I don't like it, I can make it a different number. Here's my numbers. If I say I want to spread them more, that's good. All I got to do now, make W12. I don't have to go change all the other numbers. Make that 12, save it, and run it again. Compile and run. And now you have more space between them. So you don't have to go to each one of them and change that to this and that. Yes. You want to put it before you use it. So you can't put W here. You can't say int W here because the machine doesn't know what W above it. Is that what you're asking? Yeah. So it has to go before you use it. So I define it here because I'm using it here. So as long as that value is defined before you use it, you're okay. If you do it after, if I take it, move it down, I'll show you. I'm one of the people I like to show people. If I put it there, I'm going to have a problem. Cut this one. Where's cut? Cut. And let me put it here. This is not going to work. Because the machine is sequential. It starts with the first line, it goes down. Unless you make the machine jump, it's not going to jump. So when it gets to this line, it says, okay, set doesn't know what W is. So that's not going to work. Let's save this one and run it. And we should have an error. And it came back to W, doesn't know what W is. Anytime you assign a value, you want to assign it before you use it. If you're doing the length of a box, you need to get the length before you say calculate the area. You can't ask the computer to calculate the area if you don't have the length and the width given to them. You know. What about if you want to do like power function? Let's say you want to find
What about, I'm sorry to interrupt. What about aligning them to like the right or the left? Can you, is
yes.
that
Yep.
some of those functions?
Oh, yep. When we actually, soon enough, we're going to print with something called print with format. We can put the minus sign to a line on the left, plus sign to a line on the right. So when we get to print with format, we'll bring that one in. So now, what about if I want to do like this number squared, number 1 squared?
Math in that in the declaration, right?
Well, to do, what do you mean? How are you going to do math? Let's say a double SQ for squared, I guess.
You need your math to do that unless you're just going to multiply the number by itself.
That's correct. If you say num1 times num1 times num1, you don't need, oh, I use capital N, num1. You don't need to include math there because that's a basic function. The machine knows what asterisk means, multiply them. So if I say cout, notice I want my program to be user-friendly. I want you to write num1. Now I want you to write squared, the word squared, equals, and now put the answer. What did I call that? SQ. Then go to the next line. That's fine. Cout, num1, and L, yep. By the way, when you okay, file, where's undo? Edit, undo.
Close it.
Maybe, but I've been saving it, so open. I'm sure I did save it. It looks like, yep. So let's SQL here. I mean, SQL is a language actually, and L. So now if I save this one and run it, and that'll give me the square of that number. 259.79 squared equals, if you have a calculator, you can test that. And notice the machine remembers to give me 2 decimal places because I never change that. Till I change it, every number is going to be 2 decimal places. Set precision. What about if you want to do x to the power 20 or number 1 to the power 20? You're not going to write num1 times num1 times num1 20 times. So we do have a built-in power function. And if you want to use that, I'll show you what that function looks like.
Unknown caller.
Pennsylvania. I don't even know anyone in Pennsylvania. Let's do power function or power, just right, because you don't know it's called power, by the way. But if you don't know, you go power function in C++. If you're not sure if there's one, just write it in. And they should show you a power function. Where is it? Power, right there. There's a built-in function called the power function. But to use that function, notice the sample program. It said to use it, you need to include math.h or CMath. That might be a Mac one, math.h, but you can do CMath, include CMath. So if I go back to my program, where's my program? No, oh, actually. So I can say pound include here. CMath. Go get that math package for the C language, C++. And if I want to find the square of this function, and instead of saying num1, I can say pow. That's the power function. Num1, comma 2, to the power of 2. Include, oh yeah. Include CMath. And now I say, give me the power of 2. If you want to do the power of 20, power 20. Want to do the power of 30, power of 30. So that will give me the power of 20. So I'll leave it as power of 2 here. And if I save it and run it, compile and run, and it's the same number. Notice 67444.09. There's a lot of built-in functions in C++. There's sine, cosine, inverse cosine, SQRT, square root, ABS, absolute value. But to use any of them, you can include CMath. On the program we saw, it says include math.h. If I put math.h here, that's what the sample told us. And it's the same answer. So math.h or CMath, it's really the same thing. The machine knows to go include that C program. So if you're not sure about something, just type it in Google. It's like, I want to do a power function. Like, for example, let's say you want to do a square root or absolute value. You go, but I don't know what the function for absolute value. Just write absolute value function in C++. Or inverse sine in C++. And it will tell you, okay, put include math, inverse sine, a sine. And notice the resultant radius. It tells you that. So if you want to find the inverse sine, there's a built-in function. Inverse cosine, inverse tangent, hyperbolic sine, hyperbolic cosine. Notice if you want to define something as constant like pi, instead of defining pi, you can say constant pi equals 3.141. You know, we did that last time. Where's the clock? Is it a clock? Oh yeah, I see it up there. Okay. Most of these, actually, I talked about them on the video for this week. There's, I think, 7 or 8 videos for this week. Somebody recommend to the people in the back here last time. He said, you know what? I found it helpful for homework number 1 to watch the video from week 3. I don't know if anyone watched them or not, but in week 3, I talked about the CN, C out, set width, set precision, other built-in functions and all that. And there's also recording from previous years. You can watch the recording if they're still there. Sometimes actually the recording get wiped out because they're just holding a space and they don't want to hold the space there. So I'll just get rid of them. Just trying to remember what else maybe I need to talk about. I put notes for myself. No. Did I leave any? No. I'm just looking at I print all the programs after we leave. I print them just to make sure I have copies of them. If you want to read the name, we talked about that last time. What would you do to read a name? I'm just looking at the program we did last class. You want to read a name. You want to read something else. So let's go string, for example. String name. Someone says CN. So let me go back and let me make it user-friendly. C out. Enter customer name. Because you wanted to spit that on the screen. Oh. Oh. Come on, next line, next line. Do you want sticky keys? Turn on sticky keys? No. I don't want sticky keys on. Okay.
Is it C in or C out for enter customer name?
Enter C out first. Then I'm going to read it. CN. CN. Is that my machine or your machine? Somebody. Name. CN the name. Let's save this one. And let's run it. Enter customer name. Z. And I should have spit out my name actually. So let me show the name here. C out. Maybe that's where you meant. Customer name is. Okay. My machine is going to die. I can see it red. What kind of charger do you have?
Dell.
Can I borrow you for a second?
We got.
Nope, that won't do it. Yep. Let's see if it lasts here.
You need a USB-C?
Yep.
Yeah, I got that too.
It's actually plugged in, but oh, thank you. I don't know if this will be strong enough. Well, let's see. Better than nothing.
That's for an Apple laptop. It should be.
Is it?
enough.
Let's see if I can plug it in because I see it on red. Enter customer name is, and let's spit up is, and let's put the name. And go the next line. Let's see if it's going to ask for the name. There's a point I'm trying to make here. And customer name, I type in Z. And customer name is Z. That's good. Now let's run it again. Customer name, Z Haddad. And customer name is Z. It doesn't read the space there in Haddad. It thinks these are two things. So if you're going to do that, if you're going to read a name, we said you have to use what? Get line? Which one? No, there's to read a line. If you look at what we did last time, now we have to use the get line.
I don't remember that.
You remember that?
I don't.
No? I'll show you. File open.
Was that in the lab then?
Nope, it was on the class, but it could be because we have two classes. Let me just. So today is the 9th. Could be the February 4th or February 2nd. CN, here we go, dot ignore. Enter the radius. And get line CN dot name. So when you want to read a name, with CN dot ignore, when you type a number before that and you hit the enter key, it takes the enter key as the name. So that tells the machine ignore that enter key. Don't read it, ignore it. So now it says enter a name, you type in a name, to read it, it's a get line CN dot name, and that will read the name. So if I go back to file open, and we are the 9th. So instead of CN name here, I'm gonna go get line read the name and CN name. Read the name. Let's see if that reads Z Haddad now. I type in ZN Haddad. Your name is ZN Haddad. You can put as many space you want to put in that. It's going to read it. Okay. I just looked at the clock and.
See the code again.
Yep. Next class, we're going to do decision making. That's the if statement. For example, calculate the class average. If you're average above 70, you pass the course, you don't have to take it again. If it's below 70, you got to take it again because it doesn't transfer. You might pass, but it doesn't transfer. If it's below 60, that's not a pass. So that's decision making. If, then, We're also getting some snow on Tuesday. So who knows? Yep. Who knows if we're going to have classes on Wednesday or not? Okay. Any questions? I see some people on Zoom. Any questions you guys have for me? Anything? I will, if you have questions, bring them to the lab today or tomorrow or Wednesday. Again, you can come to all the labs. Doesn't matter which one you are in. Just like the class. I have a class today, a class on Monday. I'll be recording the class on, Monday and Wednesday. I'll be recording the Wednesday class. If you can't make it, I'll record it. It will be posted there. Yes.
It's
Let's see, I'm set with them. I'm set with. And then. This is a Mac.
without.
Dell with this. Num was not declared. Okay. Num1, Num2, Num3. One of them probably capital lowercase. I'm just looking to see Okay, I'll give you your charger.
Yeah.
Let me just end this one.
Thank you.
You'll see you guys.
So you can keep it plugged in for a second.